What is a neural network? Neural networks are a critical method within artificial intelligence, AI, that enable computers to process and analyze data in a manner inspired by the human brain. These systems represent a key component of machine learning, specifically in the domain of deep learning, where interconnected nodes, or neurons, are structured in layers that mirror the brain's neural architecture. This adaptive system allows computers to learn from mistakes, continuously improve, and solve complex problems with increasing accuracy, such as document summarization and facial recognition. Importance of neural networks. Neural networks are transformative because they empower computers to make intelligent decisions with minimal human intervention. Their ability to learn and model nonlinear and complex relationships between inputs and outputs is essential for various applications. These networks excel at generalizing and inferring from unstructured data, enabling them to understand and interpret different inputs that convey the same meaning. For instance, a neural network can recognize that the sentences, "Can you tell me how to make the payment?" and "How do I transfer money?" have similar meanings. Additionally, these systems can differentiate between contextual elements, such as identifying that Baxter Road is a place while Baxter Smith is a person's name. Applications of neural networks. Neural networks have diverse applications across multiple industries, demonstrating their versatility and power. Some notable use cases include medical diagnosis. Neural networks are employed in medical image classification, aiding in the diagnosis of diseases through pattern recognition in medical scans. Targeted marketing. By analyzing social network data and user behavior, neural networks help in crafting personalized marketing strategies. Financial predictions. Historical financial data is processed through neural networks to forecast market trends and make investment recommendations. Energy demand. Forecasting. Neural networks predict electrical loads and energy demand, optimizing energy distribution systems. Process and quality control. Industries use neural networks for monitoring and maintaining production quality. Chemical compound identification. These networks assist in identifying complex chemical structures and predicting reactions. Key applications in detail. Computer vision. Neural networks enable computers to analyze and interpret visual data from images and videos, much like human vision. This technology is crucial in self-driving cars for road sign recognition, content moderation by filtering inappropriate media, facial recognition for security purposes, and image labeling for identifying brands and objects. Speech recognition. Neural networks facilitate the understanding and processing of human speech, despite variations in accents, pitch, and tone. This capability is widely used in virtual assistants like Amazon Alexa, as well as in call centers for classifying customer inquiries and generating real-time transcripts. Natural language processing, NLP. NLP allows computers to derive meaning from text data. Neural networks power applications such as chatbots, automated document organization, sentiment analysis, and content summarization, which are integral to business intelligence and customer service. Recommendation engines. Neural networks are the driving force behind personalized recommendations in various platforms. For example, Curelate, a startup, uses neural networks to convert social media activity into product recommendations, enhancing the shopping experience by automating the discovery and tagging of relevant products based on user-generated content. Working mechanism of neural networks. The architecture of neural networks is inspired by the human brain, where neurons form a complex, interconnected network that processes information. Similarly, artificial neural networks consist of artificial neurons, or nodes, that work in unison to solve specific tasks. These networks are essentially algorithms that perform mathematical computations through layers of nodes. Input layer. The input layer receives data from the external environment and processes it before passing it to the next layer. Hidden layers. These layers further analyze the data received from the input layer. A neural network can have multiple hidden layers, each extracting deeper insights and refining the data before passing it on. Output layer. This layer produces the final outcome of the processed data, delivering the result of the neural network's calculations. Deep neural networks. Deep neural networks, a more advanced form of neural networks, consist of numerous hidden layers, with millions of interconnected artificial neurons. These networks can theoretically map any input to any output, enabling them to solve highly complex problems. However, deep neural networks require extensive training, often involving millions of data points, in contrast to simpler networks that may only need thousands. Types of neural networks. Neural networks are categorized based on how data flows through them. Feed-forward neural networks. Data flows in one direction, from input to output, with each node in a layer connected to every node in the subsequent layer. These networks use feedback processes to enhance predictions over time. Backpropagation algorithm. This learning mechanism uses corrective feedback loops to adjust the weights between nodes, improving the network's predictive accuracy. The process involves making a guess, evaluating its correctness, and adjusting weights accordingly. Convolutional neural networks, CNNs. CNNs are specialized for processing visual data. They apply mathematical functions, known as convolutions, to filter and summarize image data, allowing the network to recognize critical features for accurate predictions. Training neural networks. Training a neural network involves teaching it to perform specific tasks by processing large datasets. There are different approaches to training. Supervised learning. In this method, the network is provided with labeled data, where the correct answers are known in advance. The network uses this information to learn and make predictions on new, unseen data. Deep learning in neural networks. Deep learning is a subset of machine learning that leverages deep neural networks to process vast amounts of data. Unlike traditional machine learning, which requires manual feature selection, deep learning networks autonomously learn relevant features from raw data, making them more powerful for solving complex problems. Conclusion. Neural networks are a foundational technology in artificial intelligence, enabling computers to perform tasks that typically require human intelligence. Their applications span a wide range of industries, from healthcare to finance, and their ability to learn from data makes them indispensable for solving increasingly complex problems. As deep learning techniques continue to evolve, neural networks will play an even more significant role in advancing AI and transforming how we interact with technology.